Hello, everyone, and welcome to today's webinar, Top Tips for Achieving Compliance for Laboratory Balances. I am Kaylee Bach of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Sartorius. To learn more about our sponsor, visit sartorius.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I'd like to now welcome our speaker, Dr. Holger Densow, Product Manager at Sartorius. For a full biography of our speaker, please see the Biography tab on your screen. Dr. Densow, you may now begin your presentation.
Thank you very much for joining today's webinar about compliance for laboratory balances. The webinar will be presented by Dr. Holger Densow, Product Manager for Premium Balances at Sartorius, and me, Sebastian Weber, Product Manager for Software Solutions at Sartorius, and it's divided in two parts. In the first part of the webinar, we explain how to achieve data integrity, minimize risk and the potential for FDA violations, and how digital workflows can be supported by technologies like the Cubis II lab balance. The second part of the presentation highlights important news for the pharmaceutical industries. The new chapter 2.1.7 of the European Pharmacopeia is compared with the USP Chapter 41. The differences are highlighted and software solutions discussed to ensure compliance. We will now start with the part of data integrity. Why is data integrity so important in the pharmaceutical industry? Because all of our decisions are based on data. And when we have incorrect or wrong data, we make maybe wrong decisions based on this information. And this increases the risk of compromising our product safety and quality and can have negative impact on our product itself and, more important, on our patients' health and safety. And when we risk our patients' health and safety, it can break the trust between patients, the inspectors, stakeholders, and we can lose brand reputation. And therefore, it's very important that we make the right decision based on correct data. So what is data integrity exactly? So with data integrity, we want to cover two major goals. One is to ensure that the data is recorded exactly as intended. So maybe when we transfer value from the instrument to our laboratory system, like in LIMS or ELN. And on the other hand, we want to ensure that the data remains the same as when it was originally recorded over its entire life cycle, what can be in the pharmaceutical industries more than 20 years. And the principle of data integrity also applies to handwritten records or hybrid system, like when you transfer your data manually from an instrument to an Excel notebook or to a LIMS system. So it's not only a topic what comes with computerized system. But when you use a computerized system and you have this kind of seamless transfer from an instrument to this computerized system, you will see in this presentation that it's much easier to fulfill all the data integrity requirements and follow the principles than when you work completely manually. So the data integrity is a hot topic in the pharmaceutical industry. You can also see when you take a look in the FDA warning letters. So for example, in 2019, 65% of all FDA warning letters contains data integrity issues, and these are different types of issues. Some of them are more related to the instrument itself, for example, to have not audit trail enabled or an insufficient audit trail. The other ones are more related to the documentation process, like not all relevant data was recorded, or the data was not recorded in a way that it's tamper-proof, for example. And yeah, I would like to show you now in the next minutes different types of data integrity violations, what can be found in FDA warning letters, and how you can prevent them with a modern laboratory instrument with workflow guidance and all the required features for data integrity and compliance, like our Cubis II balance from Sartorius. So my first example shows you directly why a digital workflow guidance can help you to prevent data integrity issues, and on the other hand helps you to bring more efficiency in your laboratory work. So in this finding, all the data from the instrument was first recorded in an official spreadsheet and then later transcribed to an official form or system. And also in this finding was mentioned that the spreadsheet showed falling results above the limits the company established in their procedure. And here it's a very good example. When you have a digital workflow, you can make sure that everyone has followed the procedure or your SOP to generate a trusted data record. So the workflow can, on one hand, automatically record the measured values. If needed, you can define in the workflow calculations, so the user have not to do calculations manually, and this also prevents a lot of error potential. And at least the digital workflow can also evaluate results and check if the results are within the given limits or specification. So you can make sure with the digital guidance that all your procedures are followed and the data is directly recorded. Here in the example with the Cubis II balance, you see we have these guidance with our Q apps directly on the balance screen. So the user gets all the information what he has to do on the screen, and if there is any calculation, we can perform it directly on the instrument. We can then also show the user at the end the results before he prints the results or send it, for example, to the LIMS system. Yeah, our next FDA finding is a quite common one. So here it is possible that a user logs in via a shared account, for example, operator or administrator, into a system and can create data or change system settings without traceability. And therefore, you should make sure that the computerized system can only used with a personalized user account, so that you exactly can see who make some changes in the system or who generates data on the system. And on the other hand, this user account should also be protected via a strong password for the authentication. And we recommend that this password should follow your company rules. So therefore, it should not be given by the device manufacturer. It should be possible to adapt these password rules to your company needs. Yeah, in an optimal case, you have an instrument integration into your company domain so that the user can use the same password as he used typically to log on onto Windows. This makes it on one hand easier for the administration because you only maintain the user accounts in your company domain, and on the other hand, it's also easier for the users because they have only to remember one password and not a separate password for each instrument. So for example, with Cubis II, we have the possibility to directly integrate the balance into your company network via Audit, so that the user can log on the balance instrument with their personalized domain user accounts. Yeah, the next problem is also a very common one regarding user management or user accounts, and this is when a user has too much rights on a computerized system and can use this right to manipulate data or experiments result. So in this warning letter, for example, the analyst has the possibility to change the system date and time and use this for setting the clock back to repeat some analysis. And to prevent these kind of issues, you should make sure that each user account has also only the rights what it's needed for the work. So you should also make sure that an administrative user has only administrative rights and not the possibility to perform any analysis. And on the other hand, the laboratory operator or technician has only the rights to perform analysis, but not rights for making some changes on the system. Yeah, but this FDA finding shows also another important thing, and this is that you have also every time the correct time for your to your results. And to make this sure, we also recommend that you have an automatic time synchronization feature for your instrument so that you can make sure that your instrument or your computerized system runs always with the correct time. Yeah, in the next warning letter here, the FDA mentioned the importance of the audit trail in their warning letter. So they write directly, the use of audit trails for computerized analytical instrumentation is essential to ensure the integrity and reliability of the electronic data generated. And therefore, you should always make sure that your computerized system has an audit trail, that it always be activated. We from Sartorius and our Cubis II balance, for example, have always the audit trail activated and it cannot be disabled or deleted. And you should not only have the audit trail, what documents all the important events on the instrument, you should also review the audit trail entries in a regular way. So you should have an SOP in place where you describe these audit trail reviews and also documents the audit trail reviews. And also, it's important that the review of the audit trail is easy for you, and therefore it should have a sort filter and also an export function from the instrument that you convenient review the data, and also with the export function to archive the audit trail data easily. On my next slide, I only copy one sentence from an FDA warning letter, and this is laboratory records fail to include signatures. We know for a trusted record, it must be signed by the individual who creates the record, and this applies for paper-based record, also for electronic records. And the good thing is, with an electronic workflow, we can to make sure that this is fulfilled, because we can easily say at the end of the workflow, after a review of the data, the individual has to sign before the record is created. So it's also a very good example again how an electronic guided workflow can help you to force your data integrity initiative. Yeah, here we have also a very important topic, and this is backing up your instrument data. Especially for a standalone laboratory instrument like a balance, we have quite often the case that you take care about your process data, like the single weighing result. But what is with all the other data on the instrument, like audit trail, calibration logs, and method configuration, for example? They are also GXP relevant and has to be stored over the entire data lifecycle. But when you only store the data on the instrument, you can have the problem that the instrument broken, and then you also lose your data, and therefore you should also have the possibility to back up these instrument data in a secure place. In an optimal case, it's like our Cubis II balance that you can transfer automatically in a regular way the data to a network storage. And also another point is that you can also have the readability of these data in 10, 20 years. And therefore, you should make sure that only standard file formats like PDF are used that are also readable in future. Yeah, in our next example, you can also see how a modern laboratory instrument with digital guidance on the instrument can help you to avoid any problems. In this FDA finding, there was mentioned you failed to challenge the analytical balances for minimum weight, measurement for uncertainty, and drift value. And here we can easily avoid, for example, with our Cubis II balance, because on one hand, we have implemented workflows that helps you to determine the working range of your laboratory balance. And on the other hand, we can make sure that there is no weighing below this minimum sample weight. So otherwise, the workflow on the instrument blocks the takeover of the measurement. And on the other side, we can also automatically display and document the measurement uncertainty for each weighing value directly on the instruments. So you can also see here that digitalization helps you a lot to avoid problems and document things automatically. Yeah, in my last FDA finding, I would like to highlight the importance to monitor the status of your computerized system, because when you have some mail functionalities like power interruptions or connectivity problems, this can also lead to lose data on your system, and therefore you should always monitor the system status and also investigate when there are some mail functionalities. Therefore, the instrument should bring some functionalities that you easily can see what is the current status of the system, and also have some log files what you can review on a regular basis for later investigations. And it's also very important that all the messages on the systems are in a natural language, so that everyone directly see if there is any mail functionality and what is the mail functionality. So for example, with the Cubis II balance, we have a clear status center where you directly see what is the current status on the instrument, and we have also the possibility to block the weighing when there is any mail functionality, to avoid that anyone performs weighing jobs without a proper instrument. So at the end, I would like to summarize all the features that a computerized system should provide to automate processes as much as possible and to support your data integrity initiatives. These are a backup functionality for all the GXP relevant data, like process data, but also audit trails. Then it should have an audit trail functionality that logs all the events in the system, and especially for laboratory balances, it should also comes with a alibi memory where all the weighing results are stored as a reference. Yeah, then the instrument should come with a proper access control and user management, so that user always have to log in with a personal account for a high traceability and have all the rights what they need for their daily work. Yeah, then it should provide an electronic signature functionality, an automatically time synchronization, that you always have the correct time on the instrument, and it should have a proper digital user guidance that your employees have to follow your SOP, that the data is automatically logged, and if there is any malfunctionality or any out of specification result, the user is warned. Yeah, thank you very much for participating in the presentation, part 1. I hope I was able to show you how a computerized system can prevent data integrity problems and increase efficiency in the lab. All examples were shown by using the Cubis II balance from Sartorius, which is a standalone instrument with full 21 Part 11 compliance and extensive connectivity options without any additional software or middleware need. Cubis II is a fully configurable weighing platform that can be customized to your needs, and if you want to have more information about this, please visit our homepage sartorius.com. I will now take over to the second part of the presentation to my colleague Holger Densow. Thank you.
In this presentation, I will talk about the new chapter 2.1.7 of the European Pharmacopeia. I will highlight the differences to the USP chapter 41, and I will talk about Sartorius software solutions to cover this topic. I will start to talk general aspects of the new chapter, then the differences to the USP chapter 41, upgrades to the QAPS minimum weight and USP advanced, and in the end I will give a short summary. The new chapter of the European Pharmacopeia deals with balances for analytical purposes. It became mandatory on the 1st of January this year and affects pharmaceutical companies manufacturing drugs for the European market. So this new regulation does not only affect companies located within the European Union, but manufacturing drugs for the European Union. The new chapter focuses on best practices for installation and usage of instruments. It highlights the importance of calibrations and their documentation and certificate, including the measurement uncertainty, and supports the life science management of instruments based on the performed tests and calibrations. The European Pharmacopeia Chapter 2.1.7 lists a lot of general considerations for analytical balances, like for example, it defines the SI units as force is mass multiplied by gravity. It defines the balance types, mechanical, electronical, and their resolution, and it deals with installation and location. The new chapter gives clear guidance how to monitor environmental conditions at the installation site, like temperature, humidity, and barometric pressure, and gives recommendations how to avoid air currents, dust, electrostatic forces, magnetic forces, and vibrations. To deal with these topics, Sartorius offers different technical solutions, and these are mentioned in brackets on the slide. To measure environmental conditions at the installation site, we offer climate modules and a software for air buoyancy correction. To avoid air currents and dust, special draft shields, weighing pen or covers can be used. For the elimination of electrostatic forces and magnetic forces, ionizers and anti-magnetic weighing pens are available. And to avoid vibrations, weighing tables can be used. In addition to these general considerations, Chapter 2.1.7 also deals with the equipment performance, in detail about calibrations and performance checks. Regarding the performance checks, there are some differences between the European Pharmacopeia Chapter 2.1.7 and the USP Chapter 41. On the next slides, I'm going to talk about the similarities and differences between the two chapters. The performance checks include a repeatability and accuracy test at the installation site, but there are some differences between the two chapters. According to the European Pharmacopeia, the systematic errors determined in the accuracy test must not be greater than 0.05%. So this limit is more strict than in the USP Chapter 41, because according to USP, 0.1% are allowed. In addition, the European Pharmacopeia gives clear guidelines on the test loads. For the repeatability test, the test load should be between 100 mg and 5% of the maximum balance capacity, and for the sensitivity test, the test load must be between 5% and 100%. USP Chapter 41 doesn't give that clear guidelines on the test load, and in theory, the performance checks could be passed using only one single test load. So conducting performance checks compliant to USP Chapter 41 does not necessarily lead to compliance to the European Pharmacopeia Chapter 2.1.7. Concerning some other aspects, USP Chapter 41 and the European Pharmacopeia Chapter 2.1.7 do not differ. According to both chapters, the performance checks must be conducted at the instrument's installation site. Using the standard deviation S of the repeatability measurement with at least 10 repetitions, the minimum sample weight is calculated. To calculate the minimum weight, the standard deviation is multiplied by 2000. If the standard deviation is lower than 0.41, this equation is replaced by 2000 multiplied by 0.41 multiplied by the scale interval. So in consequence, the calculated minimum sample weight cannot be lower than 820 multiplied by the balanced scale interval. Since the performance checks are conducted in the installation site and the standard deviation S is taken for the calculation, the ambient conditions are considered for the calculation of the minimum sample weight. According to both chapters, the performance checks should be conducted at regular intervals, and of course the measurements shall be repeated if the balance is moved. So the minimum sample weight limit is identical, but the requirements on the performance checks are slightly different between the two chapters. So what solutions are available from Sartorius to maintain compliance to the new European Pharmacopeia Chapter 2.1.7? Sartorius offers two software solutions, so-called Q-apps, for Cubis II balances to cover the requirements of the new Chapter 2.1.7. The first software application, minimum weight, controls that no weight values below the allowed minimum sample weight are acquired. The second software application, USP Advanced, offers guided workflows for performance checks to determine the permissible minimum sample weight. The software application minimum weight allows to select between different guidelines like USP Chapter 41, the European Pharmacopeia Chapter 2.1.7, Euromed CG18, SQ-min or user-defined. The software application allows to set the starting point of operating range, also called OR min value, that is given on the balanced calibration protocol. If a minimum sample weight according to USP or the European Pharmacopeia is to be set, the software application includes a plausibility check for 820 digits. So based on the balanced scale interval, the software application checks that no minimum sample weight below the lowest allowed limit is entered. If the function set weight values below the minimum weight to invalid is activated, the minimum sample weight is shown in red in the weighing screen and the takeover button is inactivated. Using this mode, the acquisition of weight values below the allowed minimum sample weight is blocked. Alternatively, to determine the minimum sample weight by a balanced calibration, the software application USP Advanced can be used. The software application allows to conduct a performance check according to USP or the European Pharmacopeia, and it displays recommendations for the test loads if the European Pharmacopeia is selected. The software application offers a guided workflow for the sensitivity and repeatability test in combination with a compatibility check of the determined minimum sample weight. At the end of the test, the user gets an information displayed if the calculated minimum sample weight complies to the requirements. The screen additionally offers to set the minimum sample weight, that is then used by the software application minimum weight. As discussed before, the software application minimum weight can control that no sample weights below the permissible minimum weight are acquired. Before I will give a final summary, just a few words on the minimal sample weight and its usage in the pharmaceutical industry. According to USP and the European Pharmacopoeia, it is forbidden to acquire sample weights below the minimum weight, so in best case 820 multiplied by the scale interval. The effective minimum sample weight of a balance depends on the environment, so on the installation site and the ambient conditions. It's important to know that by definition, the minimum sample weight refers to net values, so using a high tare weight does not lead to a higher permissible minimum sample weight. Instead, the balance sensitivity must be high enough and the balance must be installed under good conditions to offer a low minimum sample weight. Using vessels with high tare weight is not a solution, and in worst case, the FDA issues warning letters if USP Chapter 41 is violated. In summary, the European Pharmacopeia Chapter 2.1.7 defines the general requirements for analytical balances used in the pharmaceutical industry. The minimum weight is defined like in USP, 820 digits or higher. It provides clear guidance on test loads used for the repeatability and sensitivity test, and it has a tighter requirement on the systematic error than the USP 0.05% versus 0.1%. To maintain compliance, Sartorius modified the QApp's minimum weight and USP advanced according to the European Pharmacopeia Chapter 2.1.7. In the software application minimum weight, the user can select between different guidelines now, and a check for 820 digits has been implemented. To the software application USP Advanced, a performance check procedure according to the European Pharmacopeia has been added. The software application checks if the determined value for the minimum sample weight complies with USP of European Pharmacopeia requirements. If the value is compliant, it can be set by the software and used by the software application minimum weight to prevent the acquisition of weight values below the minimum sample weight.
Thank you very much for joining our presentation today. I hope we gave you some new insights into the topic of compliance for laboratory balances. Please feel free to ask us if you have any questions or visit our website if you want to have more information about the presented instruments.
Thank you, Dr. Densow, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. All right, let's get started. Our first question here asks, do I have to administrate users at the balance, or can I connect the balance to out LDAP server?
Well, that's a great question. Well, of course, you can administrate users at the balance, but if you own many balances and you're working in a larger company or a larger lab, and it gets cumbersome to administrate all users on all balances. So yes, the answer is you can hook up the balance to your local LDAP server, and then the users are created on demand in the balance, and they can use their Windows or Linux password. That's possible. Yeah, so using an LDAP server is a far easier way to administrate the balances and to keep the user management up to date than doing it locally on the balance.
Great, thank you. Next question here. What happens in case of a power failure? Is measurement data getting lost?
Well, if the balance has got a power failure, if you're working in a task, in a weighing task, and the power switches off, the reporting data will get lost, but not the measurement data. So in fact, the balance collects data in a reporting queue and in the raw data memory. So the raw data memory is the so-called alibi memory. And here, measurement data are written immediately into the memory. So this data is not getting lost, and only reports are getting lost. So you can always have a look to the alibi memory if in case of a power failure, and you can have a look which values were recorded by the balance.
Great. Another question we have here asks, if the balance exports results to a server, how is the data protected against manipulation? So how can I be sure the data integrity is maintained?
Okay, yeah. Also a good question, because if you export data to a server, you can, as a PDF file or CSV file or whatever, of course, this data could potentially be manipulated by users, and a protection against these manipulations is the following mechanism. So all reports, the balance exports, have an additional checksum, and this checksum is also entered in the audit trail. So whenever you're in doubt of your data integrity, we can check the original checksum of your exported files. And first of all, so if for the exported files the checksum doesn't match, you can be sure there has been something manipulated. And the second mechanism is to additionally control the original checksum in the audit trail, because also the checksum might be manipulated. But at the balance in the audit trail, the checksum cannot be manipulated, that is recorded. So you have got always, let's say, a raw data of the original checksum, and by comparing these checksums in the original files, you can always find out if your files have been manipulated or not.
Great. Well, it looks like we have time for one more question here, so we'll wrap up with this one. Is the balance 21 CFR Part 11 compliant, or does it support compliance?
The balance itself cannot be 21 CFR Part 11 compliant, because according to the FDA guideline, also some measures have to be taken by the users. Here in detail, the IT environment of the lab. So the balance alone cannot be CFR compliant, but with the right measures of your IT department, the complete system can be CFR compliant. For the balance, for the Cubis II balance of Sartorius, we offer a CFR compliance checklist, and in this checklist you can see how the balance matches this CFR compliance, and for which requirements you have got to take measures in your RT environment. So I guess the question is somehow a little bit, or the aim of the question is somehow, can I get something like a statement or a certificate that the balance is CFR compliant? And the answer is no, because the IT also has to take some measures to support the CFR compliance. For the balance alone, no.
Great. Well, thank you again, Dr. Densow, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Sartorius, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today, and those submitted during the on-demand period, will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Goodbye.